Hello guys, welcome back. In the last video we have done the trajectory of projectile, which is parabolic in nature, and I had said that we'll be doing time of flight, or then time of ascent, time of descent, and all those things in the next videos to come. So now here today let us do this time of ascent and time of descent and time of flight for that. Okay, so this is our projectile. It starts from ground and ends on the ground. Okay, initial velocity, as we have already said, it is u. Theta is the angle of projection. Okay, my horizontal velocity is u cos theta, and vertical velocity is u sin theta. My final point is A, and B is the point of maximum height. Okay, now if it reaches maximum height, what does it mean? The height cannot increase more than that. And why the height doesn't increase? Because my vertical component of velocity is going to become 0 over there. Okay, had it not been 0, it would have moved further, it would have moved further up, right? But then it is not. So that means my vertical component of velocity is going to reduce to 0. So now let us talk about this vertical velocity, the vertical motion, let us say. And my initial vertical velocity is u equal to u sin theta, correct? My final velocity in the vertical direction is equal to 0 at point B. So I am going to write here between O and B, O to B. Okay, so u is u sin theta, V is equal to 0. Acceleration is obviously acceleration due to gravity, which is minus g here. And I want to find the time taken for ascent, time taken for reaching position B there. Correct. So T, I'll call A, T A, T ascent. Okay, that is equal to question mark. Now how do we do this? We can use the first kinematical equation, very simple, which is V is equal to U plus AT, correct? So my final velocity at point B, it is 0, is equal to U is U sin theta minus G into T A, that is T, time of ascent. Therefore my time of ascent is equal to how much? It is U sin theta upon G, correct? So that was about time of ascent. Now you need to find time of descent. Okay, how do you find time of descent there? For that we have two ways. Now one way of doing that is, you know that, if you consider motion from B to A there, how would you do that? The velocity at B is 0. Okay, so initial velocity is 0 at this point, and then final velocity, okay, final velocity will be something. Okay, we don't know how much it would be, but then acceleration acting is how much? Acceleration acting is it is gravity. You know that. What is this distance? So for that we need to either calculate this distance, which is the maximum height, and then get it, or then there is one more way. Okay, now what is that other way? See, I start from point O, okay, and I am landing back again at point A. So what is the vertical displacement between points A and B, O and A? It started from here and it landed here, correct? Is there any vertical displacement? No. There is some distance traveled in the vertical direction. It was some distance of ascent there, and then distance of descent. Okay, so this plus this is the distance traveled, but there is no displacement. So displacement over there would be 0. So for motion, I'll change the color here. So from O to B to A, I start from O and I land at A. My displacement, vertical displacement, is equal to 0, right? My acceleration here is equal to minus g, and time taken is equal to, how much is that? Time taken is time of flight, total time. Okay, time taken from O to A. Okay, so let us use second kinematical equation again. So S is equal to ut plus half at square. Correct? My displacement is 0, vertical displacement is 0. Initial velocity is how much? It is u sine theta into t minus half g into t square. Even this is capital T, total time we are taking, right? Now, now here you can take this t common, so t is common, so u sine theta minus half gt, right? And that is equal to 0. Now if you look at this equation will be satisfied when either my t is equal to 0 or this bracket is 0, or u sine theta minus half gt equal to 0. Now that makes perfect sense, right? Because at t is equal to 0, I am here, and at the point of starting, my displacement is 0, vertical displacement is 0, so that is quite logical. So this is all right. Let us go for this, okay, and then that would tell you this, okay, this position, that is point A there, okay. So half gt is equal to u sine theta, so t is equal to 2u sine theta upon g, correct. So that is the total time of flight. Okay, so what I did, first of all, I got time of ascent and then I got total time of flight. Okay, so I have time from here to here and I also have time from here to here, correct. Then time from here to here would be the difference between those two, isn't it? So time of descent is equal to total time of flight minus time of ascent, and that is equal to 2u sine theta over g minus u sine theta over g, and I'm going to just put this line here so that it's not confusing, doesn't become confusing. So that would be equal to, I'm coming here, so it will be u sine theta upon g, correct. So now here you will notice one thing, that my time of ascent and time of descent, they have same magnitude, correct, and total time of flight is double the time of ascent or double the time of descent, right. So that was about the time of ascent, time of descent, and total time of flight. Okay, in the next video we are going to talk about the maximum height reached by a projectile. Thank you so much.